To start off our discussion, I want to do a bit of a review of basic object-oriented programming, but we're going to do this quickly and look at several features together. Object-oriented programming is based on types. We have classes and interfaces, and some of them are going to be concrete types, which we'll call classes, and some will be abstract types like abstract classes and, of course, interfaces. As a quick example, let's take a look here. I have a class called employee. Now, employee here is listed as an abstract class. Uses the keyword abstract. The keyword can go after the word public or before. It just has to go before the name of the class, before the class keyword here. And an employee is simply going to be a collection of an integer ID, a string name, and a local date called a hire date. Now, if you've used Java before, but you haven't used a lot of Java 8 stuff, the first thing that'll jump out at you is this local date class. That's from the new java.time package, and we'll talk much more about that later. For the time being, let's just consider it to be a regular date without a time part to it, so it's just a representation of year, month, and date. This is a class that I will revisit later when we're talking about Java Persistence API. The ID here is going to wind up being a primary key, or it's going to map to a primary key in a database table, and the columns will be the string name and the hire date. At the moment, because I want to keep this very simple, I have a static attribute called nextID. Static implying in Java that this is a class level attribute. It's one per class rather than one per instance. And that means that when I hire a new employee or when I instantiate a new employee, I'm going to increment that nextID property and use it as the value of the ID. So I'll use the current value and then increment nextID so it'll be ready for the next one. I also have a constructor here that takes a name, and I will supply the name as an argument and then save it as an attribute of the class. And then for the hire date, I'm using a method inside the local date class, a static method called now, which returns the current date right away. So I'm not putting in there a way to set the hire date directly through the constructor, but there is a setter method in case we need to change it at another time. I also have a default constructor in this class. The default constructor invokes the one-argument constructor using this as a method name. Now that's something I do want to go over for a moment because that's something that often gets glossed over in an introductory course. We have the keyword this and we have the keyword super. Both of those come up in two separate contexts. If you have the keyword this as a reference, then it's a reference to the current object. And we're seeing that in this class right here, right on line 19, where I am making a distinction between the name attribute and the name parameter to the method. So whenever the name of the parameter matches the name of the attribute, the keyword this is used to make it unambiguous, to say which one is the property and which one is the parameter. So in this case, using this dot name is the attribute of the class. Now that's a common practice that most everybody gets used to very quickly. The other usage of this, the one I'm using on line 14 here, is this as a method. When you use the keyword this as a method, it is a way for one constructor to invoke another constructor in the same class. So the word this with parentheses, that's what I mean by using it as a method, is used to find a matching constructor in the same class that matches the signature. And therefore, what happens in effect is the default employee constructor invokes the one-argument employee constructor using a default name. Now I have the default name up here at the top as a public static final string. Technically, the way to reference this would be employee.default name because it is static, but when you're within the current class, I can simplify. I don't have to use the word employee as a prefix on that right away. So here I have a static and final string called default name, and here I am using this as a method in order to supply the default name when invoking the one argument constructor on employee that sets the ID, the name, and the hire date. It is very common when you have multiple constructors in a single class to have one constructor do all the work and the other constructors simply invoke that constructor using the this as a method with various defaults as the arguments. We'll take a look at that as we go along. So here I simply have two constructors, and the rest of this class at the moment simply consists of getters and setters for the various properties. There's a get ID and a set ID. Notice the set ID, by the way, in this particular case has been made private. There's no need to expose that to the client necessarily, but when we revisit this using Java Persistence API, you do have to have a setter method. It just doesn't have to be public. I have a get and set for the name property. I have a toString method at the bottom that we'll revisit. And I also have my single abstract method, which is called getPay. The idea is that in this particular system, there are going to be different types of employees that are distinguished by how their pay is computed. We'll have salaried employees and hourly employees and potentially commissioned salespeople and temps and contractors and executives, and they all have their own way of computing the pay. In this particular case, I'm an employee. I'm in a generic employee without specifying how the pay is computed, and in order to make it possible to do that, I'm putting in the method as abstract. Now, why have the method in there at all? Why have a getPay method inside employee at all? And the reason is that I would like ultimately to make a collection of employees in my HR class, if you will. I would like to loop over the collection, invoking getPay on each of them, and have each type of employee use the proper calculation based on its type. So in order to loop on a collection of employee references, I need to have a getPay method in employee so that when I want to invoke that method, it's available in the class. But of course, there's no default implementation because if I don't know what the kind of employee is, I don't know how their pay is computed. So I've made the method abstract. So when you make a method abstract, that requires you to make the class abstract. So that's the first consequence. And the second consequence is when you have an abstract class, you can no longer instantiate it. So abstract classes cannot be instantiated. Of course, I can have references of this type, and I will. The other consequence of having an abstract method is that child classes must override that method, or they will not compile unless they too are abstract. With that in mind, I have a class here called salaried. You can see salaried extends employee, has a default salary. I figure this is a Java developer in Silicon Valley, so let's give him a decent salary here. I have a salary attribute, and I have a couple constructors again using the word this. Now I mentioned we also have the keyword super, and here in the third constructor, the one that has both the arguments, the name and the salary, I'm invoking super as a method. Just as this as a method invokes another constructor in the same class, super as a method invokes another constructor in the parent class. So the idea here is that when you instantiate a salaried employee, providing a name and a salary, it invokes the single argument constructor in employee that takes a string, providing the name, and then when it comes back from that, uses this as a reference to assign the salary. My one argument constructor, taking only a name, uses this as a method to call the two argument constructor, and I also have a default constructor. Now in the default constructor, I didn't put in this at all, and I did that on purpose just to point out when we run it that means it will invoke the default constructor in the parent class. Effectively, every constructor invokes its parent using super with no arguments. So as long as the parent has a default constructor, we're fine on that. And if they don't, then we'd have a problem. So for example, if I go into employee right now and I was to comment out the default constructor, so I've commented it out, I have immediately broken the salaried class because the salaried class is trying to call super, and it says there is no default constructor available in the employee class. Now I could say, all right, let's call a different one. I could call super with, say, employee.defaultName, and now I'm back to being okay, although in reality what I would normally do on something like this is I would call this with employee.defaultName and salary.defaultSalary, and therefore have all of the constructors ultimately invoke the multi-argument constructor and have that one do all the work, calling super, etc. Now, I didn't do that because effectively this is the behavior I get anyway, because what you'll see is that I will wind up by default with my default salary. In fact, I've already initialized my salary to the default salary, so I don't really need this one. And when you wind up calling super with no arguments, I get the default constructor, and when I restore my default constructor back here in employee, you see it's already using the default name. So in effect, everything here is already doing what I just described, and we'll be able to watch that process when I start running some of this. Now, of course, in this class, if I want it to be a concrete class, then I have to have a getPay method, and that's what I have down here. There's the override from the parent. GetPay, I'm just assuming that the salary is being paid twice a month, 24 times a year, so I'm simply returning the salary divided by 24, and there you have it. So the abstract class is useful because if a class has any abstract methods, it has to be an abstract class. It forces all child classes to have all the abstract methods in them and implement them, or otherwise they too are abstract. And the only price you pay is that you cannot instantiate an abstract class, but I can still make collections of these. In the next section, I'll put all these things together, and then we'll be able to execute this and see how all of these methods are invoked during the process.